But it is a real privilege to be with you, and it's great to hear all those updates from the various PRISMs, because your groups are those who, which are on the front lines of actually trying to put our understanding of invasive species into practice. And so it's a pleasure to be talking about that. So I want to start, I'm a scientist, I'm an ecologist by training. I've been working on eDNA for a long time. I'll come back to that, but I want to start with just sharing a little bit of the ongoing, what I regard as sort of amazing ability that we have in the scientific community to keep getting more and more information out of eDNA. So here's just a recent cover of Nature, a leading scientific journal, that relates the recovery, the description of a whole ecosystem in Greenland that existed 2 million years ago. And this was, its work was done from ancient environmental DNA, eDNA that's been preserved in sediments and under ice in Greenland for over 2 million years. So that's just astonishing. So that's the kind of thing that is symbolic of our rapid ability in the scientific community and then the research and development community to get more and more information out of eDNA. But that's not actually what I want to focus on today. I don't want to focus on the excitement and cutting edge science. Jose and I love that sort of stuff, and we do some of that. But I want to focus today, given this group, on the intersection of scientific advances in eDNA and how that can be taken up in a more rapid way, a more effective way in policy and management. And so Jose and I are both with you here. I'm going to give the presentation today, but Jose and I will both be available for Q&A afterwards if there's time, which I hope there will be. And it's our hope from our roles as scientists at Cornell to not only be pushing the boundaries of science and getting more information out of eDNA and figuring out how to do that, but also to be helpful at that interface and helping transition eDNA into practice in management. And Jose, for example, runs a eDNA analysis lab at Cornell. So my own background in this area is I've been working for a long time, decades, on invasive species issues, and starting in 2009, developing and applying at the same time the application of eDNA in the detection of species, in this case, Asian carps in the Chicago sanitary and ship canal. We were motivated, my group of collaborators at the time were motivated to do that because of questions we were getting from those agencies responsible for managing that canal in the Chicago area. How can we figure out where Asian carps are? That's what led us into our first applications of eDNA. And so I've been motivated for a long time to do science that is going to be useful in management and that's enabled by policy. So I see eDNA and the developments in it over the last 15 years as being an example of this kind of process that I've illustrated in this cycle on the slide. I regard this as a potentially sort of virtuous cycle, where if you start at the top, we've discovered ways to get more information than we ever imagined possible out of DNA floating around in the environment in rivers and streams. And that has prompted advances in management policy. Just to go back to the Chicago Ship and Sanitary Canal, our discovery of that led to a much more aggressive and creative deployment of new management strategies, and that continues to this day, and policies that enable that management and coordinated across state agencies and federal agencies. And that cycle's continued. So we, by discovering eDNA as a useful detection device, we enabled early detection and rapid response that had not previously been possible. That in turn creates more demand from the policy and management community for better and more useful and more information from eDNA. And the cycle continues, at least I think in an ideal world. But there are some bumps along the way. The valley of death that people talk about in the transfer of technology to useful products or practices is real, and it's real for eDNA. And so I think there needs to be some concerted action, some deliberate, thoughtful activities and shifts in perspective for us as a community, as a society, to better realize the potential of eDNA in opening up new management possibilities. So I wrote this is a 2-page commentary that you see the title of here, that was motivated by this desire. And in that piece, I mostly provide some examples of where I think there's sort of low-hanging fruit where that could be done. I'm not going to belabor those necessarily today, but what I do want to talk about is some general changes in perspective that I think would enable us in the scientific community and in the management community to work more effectively together in order to better manage natural resources that involve and are affected by invasive species. So I think one of the things that's required here is recognition of some nuance. I often hear it said things like, well, I don't trust eDNA, or eDNA is not useful. That's on one extreme, or there are too many uncertainties in eDNA. On the other extreme, I hear people often in the scientific community saying, well, eDNA should just be used by everybody all the time, including citizen science groups, and the information that results should be posted publicly right away. Those are sort of two extremes. I regard both of those, and that kind of broad statement is not being very helpful in advancing that interface between science and management, because eDNA is way more than just one tool, and a tool. eDNA is just a means to an end, and we have to define what those ends are when we talk about whether eDNA is useful or not. There's just lots of potential applications. So now I'm going to suggest in the next few minutes sort of 5 changes in perspective, or I'm going to call them mind shifts on these slides, that I think would be useful. And they're targeted as much or even more at me and my fellow scientists as they are at those of you that are on the front lines of management. And the first one of these is that we in the scientific community need to be better and more responsive to you when you ask us, hey, which applications, which tools in the eDNA toolbox are useful, ready for prime time management to the application that you're interested in? I don't think scientists feel the need to do that usually, and they won't if they're not challenged by folks involved in management to do that. We need to be able to distinguish examples like the 2 examples on this slide that I regard as sort of management-ready applications. And these are still described in a pretty broad brush. We could talk about details if you want. But there are 2 sort of combinations of eDNA technology and applications that I think have been tested so extensively and so rigorously in the scientific community over the last 15 years that we should not hesitate. You should not hesitate to use them in management applications. The first one is sort of single species detection. Perhaps it's an invasive species in the examples that you all are most used to thinking of, or perhaps it's an imperiled species where you're trying to identify the habitat to protect. The second category is what is usually called metabarcoding. That's where we're using eDNA and detecting potentially every species that's out there in a single effort. And that can be useful in other applications, particularly in environmental monitoring and biodiversity monitoring. And I'll come back to an example of that later. So that's one mind shift. In order for eDNA to be confidently used in management, though, there's another mind shift that's needed, and that is we in the scientific community and you in the management community have to demand, if that's not too strong a word, that we need some standardization and quality control. There are certain minimum practices and standards that laboratories must use, they must be designed for eDNA. Personnel must be trained. Certain protocols should be used in order for us to have sort of universal confidence, or not universal, but in order for us to have the confidence needed to use management and to use eDNA in decision making, we have to be confident of the source of that information. And I think the scientific community has got to get used to the fact that if they want to be providing management relevant information, then some agreement, some consensus on standards are needed. And I've just put up a couple of potential avenues for that. An example from our own early experience in our lab in 2010, where we got basically a certification assessment by twice, in fact, in the context of Asian carps in the Chicago Canal. Now, a third thing that we need to think about together in the scientific community, management community, is thinking about what we mean when we say, as I have said, as I hear many people say, variations on this. Yeah, eDNA is useful, and it's just complementary to traditional tools of biodiversity assessment. And I want to ask, well, what do we actually mean when we say that? That's not very useful if it just means that it's always going to be used alongside something else. If we fail to dive a level or two deeper and ask, well, exactly how is it complementary? What do we need to know about that complementarity that would enable us at that science management interface to know when it's useful, when it's more useful than traditional tools, and when it's less useful? So here's a couple of examples, and I'm not going to belabor the details on these graphs. They come from this paper that we just recently published with the title on this slide. We did this work in Oneida Lake. Probably don't need to tell this audience, a large inland lake in New York. And the question that we asked was this: which combination of tools gives us the best, the optimal list of species, the most accurate list of fish species in this lake? What is the optimal combination of tools if we're limited by time or if we're limited by money? And those in the management community are always limited by one or both of those things. So what we did was compare the results that we got from eDNA with those that we got from all the kinds of traditional tools that you see listed in the fine print on the left-hand graph there: electrofishing, seining, fight netting, gill netting, etc. And the right gives you one result, and this is when we're optimizing for work hours. We're limited by time, the amount of work hours we can put into trying to do a biodiversity survey of fishes. And the answer was, well, you're always going to include eDNA. And if you have really limited time to put into this, and the same answer applied when we ask about limitations of money, you're going to use eDNA, perhaps supplemented with a little bit of seining. And that, so this was a pretty, to our mind, not a completely surprising, but a very helpful and instructive result. We really didn't know what these results were going to look like. But the conclusion was this: for Oneida Lake, at least, for deriving a species list of fishes in that lake, if you're only going to use one tool, eDNA is by far the more accurate, cheaper, and faster tool. So, but it is, we can see quantitatively, it's complementary. If you have more time, more money to put into it, yes, you would also add some of those other tools. But this gives some very, I would regard as quite practical advice. And of course, it's only for one setting, for one goal, Oneida Lake and fishes. But I believe that we need more studies like that, and that the results will probably be not that different in other situations for other applications. But we need to test that. And that would, I think, I invite you to tell me later if that would be really helpful for management. Now, so the fourth mind shift is, yes, eDNA is complementary, and we just showed you an example quantitatively how exactly it is complementary. But I believe we need to collectively reach a consensus that in some cases, eDNA is going to be useful as a primary or even sole trigger for management decisions. Let me give you an example. When we here are three examples which I'm going to use as analogies from medicine. The first two, lung cancer and breast cancer. The medical interventions, the management step that is taken is triggered solely by indirect evidence of tumors. It's triggered by imaging. There are no biopsies typically taken for lung cancer and breast cancer. You get an image. If you see those dense spots, the surgery is done to remove them. Only after that is it determined whether or not it was malignant or not. But that's an example where indirect evidence triggers management, but because of all the background R&D in the medical community that led to confidence in that approach. The same is for a similar situation for type 1 diabetes. Type 1 diabetes is caused by the destruction of insulin-producing cells in the pancreas, but no doctor ever lays their hand on the pancreas, not even for full treatment lifetime. Treatment is prescribed solely on the basis of indirect measures, blood indicators of diabetes. Again, confidence is there about what those indicate because of long-standing R&D in the past. And I want to argue that while these analogies are not perfect for eDNA, we need to get to a point for eDNA applications, and we should be there, I would argue, after 15 years of rigorous R&D testing for some of these applications. I think for the detection of rare species, for biodiversity assessments at large scale in the oceans that are going to be increasingly needed for environmental impact statements for offshore wind, for example. These are cases where, in the second case, there's really not another tool that gives us the ability that's cheaper, more accurate, or faster and repeatable than eDNA using metabarcoding. On the left, there are reams of studies that now show that eDNA, when well done from a good lab, using appropriate protocols with all the sort of quality control that I talked about earlier, we should have confidence in those and be willing to act on them and not demand that we back up an eDNA result with a traditional tool that is much less sensitive than eDNA. Now, I suspect when I say that you might be thinking that, well, I might be willing to go along with this, but I first want to know about the quality, the standards, the protocols, and I would completely agree with you on that. You might also want to say, yes, but it's not good enough just to have one eDNA signal. We need some help understanding, well, when do we get to a weight of evidence from eDNA that would trigger appropriately a management response? And I would agree with that. And that brings me to the last sort of change in perspective that I want to put in front of you. And that's that we scientists and managers need to see it as a major task in this transition of eDNA from science to application, to work together to co-produce decision support frameworks. And what I mean by that is what comes out of extended involvement with scientists and managers, such as occurred in this set of projects that we described in this recent paper in fisheries, that led to this is a very simple, very about the most simple possible, what I would call a decision support framework. And this is from a long time ago. I'm just offering it as an illustration because it's simple. And so what it acknowledges is on this left axis is the weight of eDNA evidence. No reputable scientist is going to say, if there's a weighty management decision to be made, that it's going to be made on the basis of one eDNA result one time in one place. No, we have to talk about when do we really get confident that there's an indication of the kind of problem that merits a potentially expensive and societally costly management action. And of course, one of the other things that you want to think about is indicated in this example on the horizontal axis, which is the likelihood of secondary spread, or you might think about the likelihood of something bad happening if we don't do anything about this invasive species. So again, that's just offered as one example of what I mean by scientists and managers need to work together so that scientists understand the decisions, the impact of those decisions, the cost of those decisions, and can work with managers then to help design, okay, well, what would be a reasonable level of evidence from eDNA that would trigger a response? Here's a much more complicated decision support, and I offer it not to really talk about it or to get you to read it, but to just say this is a very active interface that's going on in some examples. This is from an ongoing study sponsored by the Great Lakes Fisheries Commission, and this and lots of other things about that decision support effort are on the Great Lakes Fisheries Commission website. But my general point here is we've got to work together to increase the confidence and the application of eDNA if we want to move it into management. And the things I'm saying are my way of saying it, are my opinions, if you will, but they are consistent with a lot of consensus that came out of a national workshop that I was on the steering committee of in September. And I'm hopeful that the White House, the Office of Science and Technology Policy, is moving toward the development of a national eDNA strategy that would address some of the things that I've highlighted today. So I'm going to stop there and I'm going to stop sharing. And I hope that I've left time for a question or two. And have I successfully stopped sharing?